Welcome to Miss Taylor's class notes, and today we're talking about algebraic reasoning and proofs. So we're going to real quickly go through these properties. The addition property of equality is if it's 3x plus 7 equals 10. Well, really the addition and subtraction kind of go hand in hand. They're just the inverse operations. We would subtract 7, and what we do to one side we do to the other. That's all that these are. So 3x would equal 3. So this one would be subtraction. If we had to add, it would be addition. So if we use that same problem, that's going to get our multiplication and our division properties of equality. So if I have 3x equals 3, to move to 3 to the other side, I do the opposite and divide so that x equals 1. This would be division. And so you know these things, we're just giving them names. The distributive property means we distribute, it means we multiply. So it means that if we had negative and then 3x plus 7, it would equal negative 3x minus 7. So we use that distributive property to multiply. And now we've got a couple of others that are new that we really haven't talked before that we're going to use a lot in geometry. So our reflexive property of equality means that a number equals itself. So we typically see this in diagrams where we have two triangles next to each other, and this side right here is the same side for both triangles, so it equals itself. Our symmetric property, usually x equals 1, is the same thing as 1 equals x. And so that's all we mean by symmetric property. Our transitive is just simply our law of syllogism. If A equals B and B equals C, then we are able to take the B's out and just have A equals C. And then our substitution problem or property is, so let's say we have 3x plus 7 equals 10, and we know that x equals 1. We can then substitute that 1 in there, and we can solve the problem. So 3 times 1, oh my goodness, pen, plus 7 equals 10. And that's all that substitution property is that we go and plug that 1 in there for that. I'm going to very, very quickly change this because it just makes things more confusing than they need to be. So if we have that angle ABC is congruent to angle DEF, and we know that angle ABC equals 37 degrees, what we can then do is say that 37 degrees equals angle DEF. And so that's our property of substitution, is we just take that 37 and we plug it in for ABC in that statement. That's the easiest way to explain that, but that is going to be our substitution property. So if we look at this property here, we have RS is congruent to TW, TW is congruent to PQ, so we can take out the middleman, and RS is congruent to PQ. So this is going to be our transitive property. So the measure of angle F equals G, so G equals F. That is going to be our symmetric property. Let me zoom out so I can make sure I spell this right. And then finally, our last one, K equals K, which is our reflexive property. So we are going to use these properties to solve equations and prove that we are solving equations. So you've got to go step by step and prove or justify what you're doing and why you're doing it. So if this is the first problem we're going to start with, again, if we've got variables on both sides, there's a whole bunch of different ways you can do it. Everyone can do it a little bit differently. So the first step I'm going to do is I'm going to subtract 3x from both sides. So the principle that I'm using is subtraction, our subtraction property. So we get negative 7 equals 5x minus 19. So now my 7's lonely. I need to add the 19 to the other side. We should get a positive 12 equals 5x, and this was my addition property. So now I'm going to rewrite the problem. 12 equals 5x. Not 5x. My brain, that's a 2. It's an early morning and my brain is not thinking correctly. That's a 2. That makes the problem make way more sense. So our final step is we divide both sides by 2 using our division property. And so we get 6 equals x, but we always want the x on the left side. So x equals 6, and that is our symmetric property. I'm going to abbreviate it there because, again, I'm not great at spelling it. And so that would be our final answer. So I want you to solve these next two on your own, giving the reason and proving it each and every single time for every step that you do. And I want you to check that with the completed class notes. All right, so we're going to skip down to this one right here. So it's going to ask us to solve for y, kind of going back to Algebra 1. So if we have 9x plus 2y equals 5, and I want to solve for y, I need to move the opposite term. So I'm going to subtract the 9x from both sides, and because I subtract, my property is subtraction. So 2y equals a negative 9x plus 5. I always like to put the x first, so that's why I do it that way. The next step to get the y by itself is we need to divide. So our step was division. And so our answer was y equals negative 9x plus 5 over 2. And since there's nothing really for me to simplify, I'm just going to leave it like that. But we can do that with literal equations as well as equations.